Hello, hello. One moment while I connect my presentation, which I'll be presenting. Hi, yes, wait. Yes, hi, I'm Brian Jordan from code.org. Who here has heard of code.org before? Handful of people heard of code.org, okay. So code.org, we're a nonprofit that does computer science education. We're basically trying to get computer science into schools K through 12. So today I'm going to be talking about continuous testing meeting the classroom. So what happens when you're making something for the classroom context? How do you test it? Why do you test it? What goes wrong when you test it? And just some stuff that we've learned over the last couple years. So I'm kind of an outsider to testing. I'm kind of just a general full stack engineer, and I've picked stuff up along the way. A lot from coming to meetups and learning from friends in the Selenium testing community. So yeah, this should be an interesting thing for people to see what it's like to learn how to start testing stuff and what happened over the last couple of years. Just show of hands real quick. Who here is a full-time tester, person who works on testing, UI testing, or yeah, like writes tests, make sure tests work and that sort of thing? Okay. Show of hands, who here is a web-focused developer? Maybe has written some web sort of stuff before, fights browser bugs. Okay, so we got a couple of browser bug fighters. Cool. Yeah, so let's jump into it. Yes, so code.org, nonprofit computer science education. We're trying to basically expand participation in computer science. So right now, not everyone has the opportunity to learn computer science. I know I definitely did not have computer science classes in elementary and middle school, nor high school either. It was kind of, you just have to learn on your own. That's not great for expanding participation in computer science if it's only after school programs that you can find, or only out of school programs you have to go out and find. So we're basically trying to get computer science classes into schools, taught alongside biology, chemistry, et cetera, so that everyone has the opportunity at least once during their K through 12 career to learn computer science. So one of the things that we do is this event called the Hour of Code. Raise your hand if you've heard of the Hour of Code. Some people. Okay, handful of people too. Yeah, so the Hour of Code, it's an event that we run where we basically challenge students everywhere, well, people everywhere, to try an hour of code. So teachers will say, okay, we're going to set aside 1 hour of school time today during a week in December called Computer Science Education Week. And they all just try out 1 hour of code. Here's a video about this last year's hour of code. Code. That's kind of a little bit about the event that we run, the Hour of Code. So what is the Hour of Code? If you couldn't tell from the video, the Hour of Code, what we basically provide is a selection of tutorials that are targeted to be about an hour long or fit within an hour class period, which usually ends up actually being around like 40 minutes with coming in and coming out and setup and all that. We try to make it a nice, easy, fun introduction to coding. So we do stuff like have Anna and Elsa from Frozen, or Steve and Alex from Minecraft, so that kids love that kind of just like seeing the characters that they like. And then what we actually do, and we'll get into actually what these tutorials look like and what we're actually going to be testing. So 200 million students, parents, teachers have tried the Hour of Code over the last few years. So it's a pretty big event, but that's not kind of the main focus of what we do. So we also are building full curricula, like entire curriculums for K through 12, so 20-hour long curricula, and we run professional development for teachers that teaches them how to teach that curriculum. Because if you're a teacher who was interested in teaching computer science, maybe you didn't study computer science because it's kind of a chicken or the egg problem there. We run professional development teacher trainings for teachers to learn how to teach computer science. The other thing is, in a lot of cities and municipalities, states, you actually can't get credit for computer science. Even if you were a teacher who knew how to teach computer science, and you were motivated to teach computer science, and you had kids who were interested in taking a computer science class, it's actually tough to get buy-in throughout your whole organization, because oftentimes you can't get credit for the elective, so it's hard to kind of fight for computer science classes to exist. So we're working on policy changes. A lot of states have actually changed their policies on that. And we have district partnerships, so large cities will say, okay, we're in to teach computer science. Let's run professional developments and that sort of thing. So that full curriculum thing, that's what I work on. So I'm a developer on our web-based drag and drop coding, starts out drag and drop coding, goes into more text hardcore coding in the later high school curricula. So we've had around 20,000 K through 12 teachers go through the training. We've had about 260,000 teachers, 8 million students signed up on the platform trying out the website. So here's what it looks like. Here's kind of what our challenge will be to test today. So as we're going along, imagine how the heck are we going to test this with Selenium. So yeah, we have, it's kind of I don't know, raise your hand if you've actually seen a drag and drop coding thing like this before. Okay, yeah, it's a little weird. So it's, instead of actually writing text-based code, you can grab these little blocks and drag them over here. And if they snap into the other blocks, then it's basically valid code. And then you can click the run button, and your code gets executed from top over here, down, down, down. And it'll repeat and all that sort of thing. And so on the left side there, it's kind of an activity area. So in this one, you're drawing a triangle using loops. And there are a bunch of other ones that are pretty fun. We'll probably see a couple of those along the way. So 2013, I think, Code.org started. The Hour of Code was at the end of that year. Very small team. I think it was like 2 or 3 or 4 engineers. I joined right after that. Developing at that time was tough. We didn't have many tests because a lot of it had been developed very quickly, right running up to the Hour of Code, a lot of manual testing. So in 2014, we kind of started the charge to get tests written. This is a funny, we had a scavenger hunt at, when we were all in Seattle for our yearly kind of team get-together meeting. And there's a scavenger hunt, and you had to kind of find stuff and take photos of yourself with different stuff. So one of them was like the heart of Seattle. You had to come up with something that would be the heart of Seattle. So someone took a photo of themselves in the main square there, and that counted as it. One of them was fear itself, a photo of fear itself. And so one of our engineers had this screenshot of Heidi's the founder of Code.org. Urgent, IETNN live site issue. Fear itself is the founder of your company emailing you about an issue they found that you didn't find. This is not actually a real screenshot. She edited it. So, So yeah, why would we bother testing stuff?
Our lights are
Oh yeah,
on that timer,
going
so.
on and off. Oh yeah, all good. Kind of, it works either way, so it's nothing wrong with that. Cool.
There we go.
All right, good. The buzz is back. It's comforting. So yeah, why bother testing stuff, right? If everything's going fine, you can find the bugs, you get emailed about the bugs. Even just beyond having other people find the bugs and impacted by the bugs, it can make development a lot harder. You can kind of be afraid to develop new features and move quickly and collaborate on stuff when you're afraid of breaking something. So we basically wanted to start testing everything. The context that we're about to test stuff in is very different and kind of provides some very different challenges than a lot of other testing contexts. So first thing, students. Classroom full of students. They have a teacher. These are teachers at professional development. Students and teachers, when they're setting up a computer to get something going, at the beginning of the class, you get the computer set up. If something goes wrong or you find a bug because you happen to be using a certain browser and the tutorial stops working or the curriculum stops working and you can't continue on to the next level, it really throws off the entire classroom. Like, you have a giant room full of children. Teacher is not sure what to do. Do we try to fix it? The kids are like, what do I do now? Why is this broken? You get like 50 hands all raised. It's kind of a mess. So it's super important to have good stability with this, because when things go wrong in the classroom, you don't have time to email support and hear back to them. It's like the hour is done. So you have to find something else to do for that period. So for us, it's super important to have our curriculum solid and work, and so that teachers can trust our curriculum will work for them. Schools. Who remembers computers in schools? Computers in schools. A lot of kind of old computers. They're not always the newest. You don't find a ton of MacBooks in all the schools with the latest version of Chrome. A lot of different stuff. We got some Internet Explorer 9. We got crazy firewall issues. We got Chromebooks, iPads. Our curriculum works on all of those things. Well, it depends on the firewall issue, but yeah, we have quite a few things to contend with here, and oftentimes we'll be finding issues. So before we had these tests set up, we'd be hearing about issues that were about very specific browsers, like my Safari on OS X. When you're on this one page, this one tutorial, and you use this one combination of blocks, it hits this thing that's a browser bug just for that one version of Safari. So imagine that times all the browsers that we support, times all the users that we have. Finding these browser bugs as soon as possible is super important and saves a lot of time. What is that? That's a lot of languages. That's like 40 plus languages. We support a lot of languages. Our site's internationalized, everything on the entire site, down to the run button right there. And we also support right to left. So in right to left mode, our entire website basically flips. So a lot of the elements on the website actually flip over and read right to left and actually lay out right to left. So you'll see there the run button. It actually is laid out right to left. So this is the right side of the page, and all of the paragraphs are that way. So if you've done some stuff with CSS before, you can imagine handling both of those cases can be tricky. There's a lot of conditional logic in there for right to left. For programmatic layout stuff, there's conditional programmatic logic in there for right to left. Yeah, and all the different languages. And we have stuff coming in from translators. So a lot of these strings that we put together for someone to translate our site from English to other languages. Sometimes there'll be weird characters in there. Someone will accidentally change a variable name or break something there. So there's oftentimes a lot of surprises across all these browsers. So we got a lot of browsers. We got a lot of languages. A lot of languages times a lot of browsers. A lot of situations. A lot of people using it. Those situations are going to be found out. So it's basically really important for us to try to find a way to automate some of this testing so we're not finding out about these things too late. Oh, okay, one more thing that's really crazy about testing for this and challenging. We use a lot of kind of bleeding edge browser technologies. So it'd be nice if we had to support all these browsers, all these languages, a ton of people, if we could just make it all super simple, like HTML forms. Those work everywhere pretty much, right? There's nothing that's going to cause any trouble there. But we want it to be fun and graphical and game-like, so we make our stuff out of stuff like SVG and Canvas, which is basically a box that you can draw stuff on. SVG is kind of like vector art that you can move around in the browser. The tricky part is there are some weird edge cases and bugs for Canvas and SVG. And these were some of the first bugs, actually, I think, that I encountered back before we had our cross-browser test set up. They're funky. Like, we're talking Firefox specifically has this set of like 5 issues that you got to watch out for that we didn't know you had to watch out for yet. Very edge casey. Safari, they all kind of have their own way they like to be programmed for that specific browser. So let's test it, because it's kind of a pain to keep getting all these bugs, one off, one off, one off, one off, and then responding to that and saying, okay, when did we break that? If you don't know how long ago you broke it, you got to look all the way back and say, oh, was that broken? And you try to figure out what actually changed. So standard types of tests, nice tests to have, unit tests, controller tests. We threw all those in, started testing early on with those. Here's kind of a breakdown of what our site kind of looks like in terms of technologies when you're looking at the web page. So at the top here, you'll see these little dots right there. That's like your progress indicator. So if you're a student going through the curriculum, you'll see it'll fill up with like orange dots, and they're like, yes, I finished all the levels, and I got 100% on them. And if they're like not orange, they're like, why is it not orange? I finished that level. That's dashboard. That's in Rails. So that's a Ruby on Rails website, connects to the database, all that sort of goodness. You have the user logins on that, all that sort of thing. Apps. That's the little box to the top left, the little visualization area. That's where we write our SVG and Canvas code, our code that makes the guy walk along and draw a thing on the thing. And we got Blockly Core. So that cool drag and drop coding environment where you can pick up blocks, drag them, turn them into code, that's a separate component. That's written in JavaScript and Google Closure Tools, a JavaScript tool set. And apps, apps is all JavaScript written. We use Browserify, which lets you include a bunch of cool packages from Node into your browser website. And so how do we test those? We use some different tools that are kind of cool tools. Phantom.js for the Blockly Core test. So we basically just run a handful of assertion tests and then run that within Phantom.js, which is a headless browser simulator that lets you run JavaScript without actually having to open up a web browser and run the JavaScript in there. On the app side, we run Mocha. Actually, that also targets Phantom.js. Mocha is a nice framework for writing your tests in a very readable way. And on the dashboard side, Rails, we use Factory Girl, a nice way to define objects for your app. And we get test coverage measuring with SimpleCov. But what about Selenium tests? We're at the Selenium Meetup. What am I talking about? Let's get to the Selenium tests. So first of all, raise your hand if you know what a Selenium test is. All right, so let's get into what Selenium tests are. So Selenium tests, what are they and why would you use them? Selenium tests are tests that you run on a browser. So instead of me going to a web browser and saying, all right, so let's say we just pushed a new version of our code. We want to make sure that it works. I go to the web browser and I click the button to go to the next level. And I drag the block to check that it clicks into place. And I click the run button. What happens? And then it works. I say, OK, great, it works. It didn't work. I go and I send an email. Why did this thing break and you did not tell me? Selenium tests are like if you replace me with a robot. And instead of having gears, it's all just a computer robot. So Selenium tests are a computer robot that runs through your website and makes sure everything works. They're pretty cool. I like talking about them. That's why I'm here. So what challenge does Selenium tests actually help with? Selenium tests help you test multiple browsers at once. So one of the challenges that we have, right, is we have a ton of browsers, IE9, Chrome on a Chromebook. We have Safari on an iPhone. We have Safari on an iPad. We have Chrome on an iPhone, Chrome on an iPad. We have Firefox on Windows, Firefox on OS X. We got IE9 on Windows XP, IE10 on Windows 10. A lot of browsers. Hard to test them all, especially yourself. So there's Sauce Labs. That's the solution right there. So what is Sauce Labs? Sauce Labs is basically a tool instead of, so if you have these Selenium tests set up that will run through your website, Sauce Labs lets you point that runner into the cloud, point it at the internet, and they have a bunch of computers, browsers, that they basically spin up new operating system instances with a new fresh browser for you, and you can say, hey browser, go here. Hey browser, what does this header say? And it will tell you what happened, and it'll send you it back in a nice, easy to review format. So when you run a test, and I'll show you a little bit of code of what these tests actually look like when you're actually writing them. When you run it and you're reviewing it, you can actually see all the different steps that were run, and you can actually see what was going on in the web browser at the time. So it shows you a screenshot. You can tab down through the different tests and review the logs and watch a playback. Super helpful. But what if you want to test your local changes? So let's say you're working on a new feature. You just wrote a new test. You don't want to necessarily go immediately run it. What you can do is use Sauce Connect, which is a tool that will actually, so really the issue is, right, you want to, when you're running a test against a browser, a test against your website, you can say, okay, go to code.org, click on this button, etc. But what if I have a different version of code.org? I just made a change on my local computer that changed some header name. And let's say I changed, or some button text. I changed some text on a button. I changed the run button to go. And there was a test that said, hey, there should be a button there that says run. So if I just checked in my code change, everything's going to blow up. Someone else is going to be like, I tried running the test, it didn't work. Our continuous integration system will say, oh no, it didn't work. So what you do is you actually you change the test itself, and then you test it against your own machine's version of it. So the issue is usually that these browsers in the cloud can't access your computer because they're in the cloud. You have this local machine. It's maybe not serving to the web. So Sauce Connect is this tool that actually connects your computer to the cloud, the Sauce Labs cloud, private connection. It can access your computer, nice and easy. There are other ways of doing it, but they're kind of a pain. Or if you don't actually need to run it against the cloud, you can use ChromeDriver, which is basically a local machine version of these browsers. So you just basically run the browser on your own computer. So it's kind of fun. When you click run, it actually pops up a browser window on your machine. Sometimes it's annoying because if you're in the middle of writing an email, it's like, pah, and it starts running the test right in front of you. But it's pretty good for running quick tests. You don't have to connect anywhere. Super straightforward. Super fun to watch. And I have a video of that running, which I will show soon. What's another challenge? How the heck do you get Selenium tests to drag and drop stuff? Right? There's like a .click. There's a input. There's a type. There's a what's the text on this thing? At least in our case, there was not a .drag this block from this place to this block. It's a very, very specific motion you have to do to connect two blocks. So we use something called jQuery simulate. So we basically run, instead of running Selenium commands and saying, hey, browser, do this, we say, hey, browser, run this JavaScript. And the JavaScript is a jQuery helper that will simulate a drag and drop, all just using JavaScript, kind of hacking in the JavaScript events so that it's a kind of realistic drag. Other cool stuff we use, so yeah, actually when we actually write our tests, we use selenium-webdriver. So selenium-webdriver is a Ruby gem that lets you connect to the cloud services. They'll web drive your web you run your test with Selenium WebDriver. You can specify where you want it to point to. So you can say, please point to Sauce Labs. You can say, please point to my Chrome driver. So you can write the same tests and not have to change them based on where you're pointing your test runner at. Cucumber is a cool tool that we use that lets you write tests using what looks like plain English. It's known as a domain-specific language. And it lets you write stuff like, and then I go to this website, and then I click the button. And those actions get executed, and all you have to do is write some English. Well, the real issue is when you have to write new commands, but we'll get into that. Parallel, we'll get into that too. We'll get there. So with Cucumber, what you end up doing is building up a library of steps that you've predefined. So sentences that you can run in your tests. So tests will actually look like a set of different sentences, but you actually have to define what those sentences do, right? You can't just write, go to my website and test it. Boom, tested. You actually have to write what that means. Well, you could actually write that, but then you have to write the underlying step for that. What does it mean to say boom tested? So this is an example one where we say, and I drag. So this is some Ruby magic here. We're using a lot of, might not look like actual code. That means you did some good Ruby magic there. This is the Cucumber syntax for generating a new step. We're going to say when I drag block blank to block blank, and then we have a little thing for some code here. And we say from, so it grabs that first part of there, to grabs that second part, and then we generate some JavaScript drag code, and then we execute that script on the browser. Cool. What else do you need when you're writing tests? You need stuff to point your tests at. So we ran into a situation where we were oftentimes running tests against levels like course 4 / stage 2 / level 4, right? So our test will say, go to that stage's level, that specific level. Cool, and that works great. And it's testing the real code that's on the website. It's like the same thing the students are seeing. That's super awesome. And then someone goes in and adds a level right before that level. So then we get a weird test failure that's like, I can't find the element thing that was on that previous level. And we're like, what? Is this level broken? Issue is the actual URLs changed between the two tests. So something that we learned was you need to make sure that wherever you're pointing your test to on your website, make sure that that URL will not change if you're explicitly calling it from that URL. So one little thing that we did was we made a special curriculum that is the test-only curriculum. We call it the All the Things curriculum because it should have a little bit of everything that covers a little bit of everything from our website. So instead of pointing our tests at specific curriculum levels that might change when someone decides to add a new level, we actually point it to this kind of fake curriculum. But it's still the real level. It's still the real behavior. So we're still testing the same behavior. And annotations. So Cucumber, when you're writing these Cucumber tests, you can put little annotations right above the test. Those are pretty helpful. So they can actually change the behavior of your test. So if you're writing a specific test that maybe doesn't work on IE9 for whatever reason, or it's a page that you don't care if it works on IE9, you're pretty sure it doesn't work on IE9, and you've told people, hey, don't go to this page if you're on IE9, but you still want to have that test. What you can do is annotate that whole test with no IE9, and it skips it when our runner runs the tests. Other kind of annotations that we found useful over the years, as student, so that annotation will actually go in and in the Rails backend, create a student, log the student in, and then continue onto that page. So if you wanted to run a test where you are logged in, you can just annotate it with as student, which is pretty handy. We also have one called DB-access. So some of our tests don't require database access. So if for one where you're actually a student, you need to go in and create a student account. You need to basically modify the database. So if you were running a test against the actual production website, how are you going to actually go in, let's say you're just some contributor developer. Our site's all open source, so someone could be coming in without any access to our database, but they still want to test. If they can't access the database, you want to mark the test as requiring database access so that it detects that, OK, you're running this test against a remote website that you don't have database access to. Great, we'll skip it. Or if you're running it against your local machine and you do have database access, then cool, we'll run that. And of course, the skip annotation for when you want to keep a test around, but you don't want to delete it and you don't want to run it. Similar to commenting it out. Probably not good practice, but it's what we do. Speed run. So remember when I said that you could run your tests against your local computer, ChromeDriver, and it pops up and stops you from doing whatever it was that you were doing? You can also record what it's doing and play it back at high speed. So what we're going to actually watch, I'll just show a little bit of it. This is going to be the Selenium WebDriver coding using drag and drop blocks. So it's a computer writing code to run on the computer. I just thought that's cool. So we had to write code that will be writing code on the website that was made with code to test the code. Let's see what happens. All right, so I sped it up a little bit. So you'll see it pops open the browser. For a lot of these levels, it drags some blocks over. It runs the code. Closes the dialog boxes, so we do a lot of that. You'll see it's solving the puzzles. It's very good at solving because it has all the answers predefined. Killing the baddies. Getting killed by the baddies. Losing the level. Winning the level. So yeah, we try to get a pretty good coverage of all the different scenarios for all the different apps. So you'll see we tested Star Wars right there. Now we're testing the drawing app, so making sure that rendering all works. This is the internet simulator. That thing is cool. Students actually both log in to this website, and they simulate parts of that each computer is a different computer connected to a network. And they send each other packets in binary or not binary. It's for a high school course. It's not out yet, but they're pilot testing. It's really cool. Yep, going through the maze. We got some Angry Birds, playing Plants vs. Zombies, making sure that all works. Great, great, great. So when one of these things goes wrong, let's say someone breaks one of these levels, instead of finding out a month later when someone finally gets around to reporting that level, we find out right when the first thing works. My recording got a little messed up right there. Then I started it again. There we go. Yeah, so as you can tell, we cover a breadth of different things. Pops open a new fresh browser each time it runs one of these. And we find out when things break. But wait. So we got a lot of tests, right? Sweet. We're finding out when stuff breaks. We're finding out when specific browser things break things. And I'll show you some examples of those later. But what about bugs that the computer can't see? Are there bugs the computer can't see? Yeah. What kind of bugs? What can so when you're making assertions in Selenium, you might say something like, oh, this header, this header on the top of the website has the text, "Welcome to my web page." Cool. And you say, hey, this header should have this text, "Welcome to my web page." And then if someone changes that, it's like, hey, this is supposed to say "Welcome to my web page," and you changed it. Not cool. But what if it's not something that's like text changing? What if it's something like a CSS style change something, right? Let's say our right to left web page, when we're making a version that's right to left, someone tweaked something in the left to right mode, but it accidentally changed how it looks in right to left mode. How are we gonna figure out whether that thing broke? right? A little minor style change, like we're not even gonna hear about that. Like our users are just gonna be like, wow, this page looks slightly uglier than it did previously. They're not gonna be like, oh, let me like send a notification that this thing moved over 5 pixels. So oftentimes web pages, that's right. That's right. So you may have read the talk description, right? So there is a way, actually, to simulate a user who is upset that the web page looks different by simulating their eyes. Oh, yeah, sorry, I kind of gave away my whole thing. I was going to describe, I thought I had this idea, right? I thought it was like a cool, new, fresh idea. I was going to this hackathon with my brother, and I was thinking, like, what's the biggest pain in my life right now? And of course, it was that sometimes pixels would move on a web page. So I thought that was the #1 thing I should address with this hackathon. So how could I check for that? Can't a computer look at 2 images, right, and say, hey, these images are different? Like, wouldn't that be great? So me and my brother, we got together. I think it was a 2-day hackathon. We put together this bootleg Heroku website. He worked on this thing that used the command line tool that compares images and colors red over the parts that have changed. This is like a web page where some of the text changed. It's like, oh, wouldn't that be cool if it like emailed you when something broke, and like then you knew. Like, so all you had to do was, you didn't even have to test anything, right? You just go to the website and it'll email you when your website breaks. Stop writing tests forever. Sounds awesome. It's really hard though. It turns out it works in some cases. Like here, that's awesome. Like it told us that the text had changed between these 2 versions, and it even sent you a convenient email. The issue we found was, we found a number of issues with this. It's really hard. Simulating something and telling it to tell you when something changes, but only in ways that are important. It's actually surprisingly tough. The one thing is, right, if some small little thing changed at the top of the web page and it pushed the web page down, this tool that we used would like cover the entire thing red. It would be like, everything changed. The entire website's different. Or if let's say you had like a counter on the bottom of your web page, right? Like this many visits, this page has had 5 visits, and then someone else visits. This page has 6 visits. Sends you an email being like, your website broke. It changed from 5 to 6. So we gave up on this project because it sounded really hard. It was cool, and I think it would be super helpful. Then I told my friend, Dave Hefner, who I think spoke at a meetup here previously, and he said, you should check this other thing out called Applet Tools. It's an actual thing. I didn't realize it was an actual thing. It's a very new thing, but he introduced me to the guy who made it, one of the guys who made it, the folks who made it. It was very cool, and it really works. So in our scenarios, what it basically lets you do is write at the beginning, when I open my eyes, well, we added this step, right? We were saying, hey, when I say when I open my eyes, I really mean, hey, Applet Tools, when I open my eyes to test, and then you give it a little identifier. And then when you want it to basically take a screenshot and say, hey, this thing shouldn't change, we have text that says, and I see no difference for, and then the name of the thing. So we can write these new tests now that basically make assertions about what the website should look like. Well, not assertions about what it should look like, assertions that the website should look like the last time we deployed it, right? It shouldn't have changed between before I made a change and after I made a change. So here's a kind of a full example of that. When I open my eyes to test, free play artist sharing, and I go to this website, and I see no difference for initial load. So it shouldn't have changed since the last time we ran this test against the same server. And then I wait to see the close button. I see the close button. I press the close button. I see no difference for after we close the dialog. So it's taking screenshots after it does certain actions. And then at the end, and I see no difference for the level complete, and I close my eyes. So when it closes its eyes, it's kind of weird. We're talking about our tests kind of like they're a robot, which is kind of fun. It will notify you when it's closed its eyes and it's found something that has changed. So here's the interface of Applet Tools. A few cool things. So it shows your tests that you've run. It basically keeps all your screenshots of all of the tests that you've run, which actually I've kind of found is kind of helpful if you need to like roll, if you're wondering like, oh, what did the website look like 3 months ago? What did this thing look like 3 months ago? You can roll back and just say, oh, here's a screenshot that we took. Even that's kind of cool. Other cool thing, remember when I said you have something at the bottom of your page that does vary, that does change, that you want to make sure you're not getting notifications every time this thing changed? They thought of that. They actually built a tool to fix it. It uses some like crazy machine learning, machine vision stuff that I probably wouldn't have made during that hackathon. So I'm glad they just did that. You take a little, you click this little button right here, drag a little box over it, you're done. It basically said, so this was a matching puzzle where you have to match what the thing does with the other thing. A lot of our curricula have that. So we basically, that varies each time you load the page. So if you reload the page, it changes the order of the questions. So we just drew a little rectangle around that, and now we don't get notified when those things change. Gives you a little interface showing you all the stuff that passed and failed. It's red if it failed. We hook that up to our continuous integration system to tell us when one of those changes came out. And I'll show you some examples of these when we visit the bug collection. Not wasting time. So we've written a lot of tests, a lot of Selenium tests. We have this robot thing that goes through our entire website a bunch and yells at us when stuff breaks. But when we've written so many of them and it's running against all of these browsers, we need at some point to speed it up. At one point, our test got to around 2 hours long. So if someone made a change during that day, and we try to deploy every day, if someone made a change that day, it could take up to an hour and a half, 2 hours to know whether that change has actually broken the website. So what we ended up doing was we were kind of afraid of writing more tests. We didn't want it to get much longer. You wouldn't find out about test breakages very soon after the change gets made. So if you get a notification that something broke, you'd have to look back like an entire day or two to see like, oh, did someone break this like a long time ago or very recently? So we kind of need to speed our tests up if we were going to continue writing tests, continue trusting our tests, et cetera. So yes, early 2014, we had solid hour each test run, sometimes up to 2 hours, depending on if things were flaky. So what we did was we started working on parallelizing our tests. So Sauce Labs has this way of running multiple concurrent VMs at once. So we were actually able to get up to like 98 concurrent VMs at once. So instead of running all the tests, like just one test the whole time, we instead like stacked them all up and said, hey, give us a bunch of computers, and then run all of our tests against all those computers at once. So it sped it up a ton. Actually, the bottleneck ended up being our test web server. If you're having like 98 VMs running very quickly through a bunch of different test scenarios, it ended up kind of overloading the server to some degree. And even our test runner, so we have separate runner instances, those were using up a lot of memory. So it made it a lot shorter. Somewhere between 20 and 30 minutes now, which is pretty awesome. And as I was saying, it reduced the delay to finding the fix. It reduced the delay to finding what broke the thing at the time. So if we're running our tests every time someone checks new code into staging, we can now say, OK, it's clearly this piece of code that just broke our tests. So you must have broke the thing. The dream is to eventually have that down to a very specific commit change. So right now, we only run our tests basically every so often. People check in a bunch of code, we run the tests. Few people run the code, we run all the tests. Few people check in code, we run the tests. That's pretty cool. So when something breaks, you kind of look into OK, who all committed stuff in the last hour or so, 20 minutes. And then then take care of that. But the dream is per pull request, per pull request cross-browser tests, which is possible. We just don't have it hooked up yet. So that would actually be what we would use something like Solana Labs, Circle CI, something where they let you parallelize or basically run a new server in the cloud, running your tests against it each time anyone pushes some new code. That's the dream. I would be so happy. I'm kind of working on that right now, but let me know if you've tried out any of those or have any experiences. I'm always looking for new stuff. Looking at Solana Labs right now. Looks pretty good. Yeah, so when failures happen, we get notified. We use HipChat. We get little messages on HipChat saying, hey, this thing broke. Someone should check this out. Sometimes, though, we'll be having these meetings, right? It's like every year I think we have like a reflection meeting, and we're all talking about what are the big pain points in our life as developers, and what can we do to proactively make our lives better. A lot of times what we end up talking about is, what if we just didn't write or run tests? Like a lot of times having to actually go and track down what broke what. Like, oh, this test is complaining that it's failing. Is it really failing? Do I need to rerun it? Or writing new tests takes time, and testing your new tests takes time. And sometimes people will be like, well, do we really find browser bugs? Are there really situations where something's going to break in Firefox and not Safari? Like, why are we actually writing these tests? So we started doing this thing called the bug collection, because I was tired of trying to remember. I was like, I think we had a Firefox bug once, but I don't remember what it was, but I swear there was one. And like, I swear these things are useful. But every year we'd be like, oh, were they useful? I don't know, guys. So I started a bug collection on the wiki. We have a lot of bugs that we've caught, a lot of browser-specific ones. So I thought maybe we could take a little trip to the bug collection and see what some of these bugs are. POW! App Lab button accidentally removed for non-admins after something else moved. So this was a courtesy of Applitools Eyes Tests. Caught this one. The View Data button disappeared. There was some admin changes going in, and I think some visibility of the button changed. Suddenly you can't access that part of the site. But we caught it before we deployed, because Applitools just catches everything, because it's like someone looking at your website and saying, hey, where did that thing go? I don't know when we would have found that, really. Like, probably would have been like weeks later. Someone's like, I thought we had a feature where you could view data. And we caught it before we actually deployed it. I love this stuff. It's pretty cool. It saves so much time. Shazam, what is this? What happened here? Something broke. Oh, yes. So Applitools kind of paints purple over stuff that broke. Over here, we lost something. We lost, I think the header got pushed over to left. Oh yeah, some of these two buttons, I think they went away, and it caused a visual change. Firefox getBBox, what happened here? Wow, this looks messed up. So this is the design recipe UI. It's basically a form that you can use to make a function. We call them design recipes in one of our curriculum. It's basically a function. You're writing a new function. But it shouldn't look like this. What is going on here? The button's all over there. There's like white text on a white background. It's really all messed up. It didn't look anything like that before. This was actually the standard cross-browser UI test caught this, because something else on the page broke. Like when we said, oh, you should be able to click this thing, it's like, that thing is messed up. That did not work. So we caught that before it went out. I'm glad that did not go out. It really was messed up. And it was Firefox only. So I think we were using getBBox, which is one of those things that measures the size of an SVG element. And in Firefox, surprise, if the element is hidden, it just crashes and stops running all your code. So only Firefox. So that's one to watch out for. But there's like 10 to 20 of those things to watch out for. So it's nice to catch those. Oh, my favorite bug I've ever found. So take a look at this web page. what's going on with that web page? Okay, so it's like a little matching activity. Nothing too special. Yeah, it's like that thing that we were looking at before, match thing. Let's do an exercise. Close your eyes for just 1 second. In 3, 2, 1. All right, eyes closed. Okay, I think I went to the next slide. All right, so what is different with this web page? Can anyone tell? What might have changed? I don't know, looks good to me. Let's ship it. So what changed? Okay, let's go back between these two slides. Let's flip back and forth. So in Apple Tools, there's this little button right here that flips from before and after. So I'm simulating clicking that button. Can anyone tell what changed between those two? What's going on with this web page? So yeah, the text in the right-hand box, that is in the, that's in one of those exclude regions. Yeah, so we're ignoring that. So it wouldn't have complained about that, but it is complaining. Scroll bar, yeah. There is a scroll bar. Anything else? The header, I think it might be the scroll bar changing the centering, yeah. You see anything at the bottom there? The line spacing seems to have changed. It's a little different. Yeah, see like the text down here at the bottom, it's going from a little bit, just a little tiny bit more. But notice how that kind of added up across the entire site. Now we like require a scroll bar here where we didn't before. So what was the difference? The line spacing somehow changed. Turns out one of our engineers was working on refactoring some of our CSS so that some of the line spacing was defined in a different file, kind of cleaning things up, just some standard maintenance. And the line height override that was previously in our scaffolds.scss file has disappeared and is now some other default value, which I imagine is slightly higher. So we caught that. That's awesome. I believe that if we did not catch that, our website would probably, to this day, be like 2 millimeters taller. Not a big deal, but you know, if you keep adding a couple millimeters here and there, suddenly you're scrolling down the whole web page. We would have just never got that. It's probably not a big deal, but I just thought that was the funniest thing. So it's always good to have a backup plan. Sometimes Apple Tools doesn't catch stuff. Our cross-browser tests don't catch stuff. Maybe we aren't testing a certain page where we don't have 100% cross-browser testing of every single feature on our website, which would be great if we did, and hopefully we're moving towards that. But you got to have a backup plan. So one of the things I was saying earlier is it sometimes takes a bit of time to maintain your tests. So if you get a failure of your test and your test runner is yelling at you saying, hey, this thing broke. Hey, everyone, this thing broke. And everyone's like, oh, this thing broke. Hey, who broke it? And suddenly, your entire team is now all looking at what broke instead of continuing on their work. What we do is we actually designate a dev of the day. So it's someone who is the developer who that day will basically respond to any test failures, live site issues, important random things, so that only one person is getting randomized all day, which is pretty helpful. What does the dev of the day do? We use some monitoring services. So we use New Relic. That will tell us whether we are having web page load changes, whether we have JavaScript errors, or whether even our application performance is going slow if the page is loading slow. PagerDuty, actually, so all of these kind of hook into this. Honeybadger is our Rails error monitor, so it'll tell us when we have Rails errors on our website and something's broken there. And Zendesk, of course, is where when a teacher does find something, they can say, hey, this thing is broken. So that does happen time to time, believe it or not, even with all of these tests. It's good to get those, to find out about those quickly and have a very nice way for them to report things. We have a nice button on the top of our screen that says report bug, and it auto-fills it with like all their browser information and the page that they were on, so we can investigate pretty quickly. PagerDuty is cool if you have to do monitoring. You can have New Relic or Honey Badger or even Zendesk of like at a certain severity level, have that actually page the person on call, the dev of the day, so that if something really bad goes wrong and everyone's sleeping, it'll call them and wake them up and they can fix it. Or decide that it's not important to fix and snooze it, that sort of thing. Super helpful. The other thing we monitor is completion rates. So we watch for when the percentage completion on certain levels goes down for specific browsers. So if Android hasn't passed a certain level, even though a number of people have tried it and previously were succeeding on it but are now not succeeding on it, it'll catch that bug. And sometimes that catches browser bugs on levels that we just didn't have in our test suite, or maybe it's something about how the level was written, that specific level that caused it to fail, that we can't test all the time. So what's next for us? What's next in this world of testing, code.org, making fewer teachers write us through Zendesk? I'd love to hear ideas from anyone. Anyone have any ideas of what might be cool to look into next? Stuff to fix? Maybe more tests? Less tests? Faster tests? What we're thinking right now, I'll tell you what we're thinking right now, is getting those per pull request tests going. So when someone contributes some new code, it'll say, that did not break the UI tests. Awesome. So we can then merge their code in without worrying that our tests are going to break down the road. Our dev of the day will have one less thing to look into and try to pick out what broke what. That's one of the things we're looking at. Yeah, generally speeding up tests, parallelizing more. Yeah, more Apple Tools tests. I think we've gotten pretty good bang for the buck for Apple Tools tests. They catch a lot of stuff, as we saw. We just don't have them. We don't have them covering our entire site right now. Who knows? Maybe crawling the website and just having those all go Apple Tools would be good. Yeah. So that's what's coming up next for us. What do we take away from this? Test all the things. Maybe not all the things. Test all the things fast, at least. So make sure your tests don't take too long. Test a lot of the things, and always have a backup plan in case stuff goes wrong. Thanks. One thing I'll mention, if you're interested in code.org's mission and helping out, we have a page all about that, code.org/help. We have opportunities like helping out in schools during the Hour of Code week. You can sign up and say, I'm interested in helping out during in classrooms when teachers are teaching stuff, and they can have you come in. Oftentimes, the students want to hear about like what you do. Sometimes teachers will have you come up to the classroom and be like, "Hey, I'm a software engineer. I do this stuff, and this is what they do." And kids ask hilarious questions, and it's a lot of fun. It's a lot of fun visiting classrooms and helping out kids. It's always kind of a trip visiting like an elementary school. It's like, whoa, what would this? That's what I totally remember this. It's kind of weird. That's pretty fun. Also, we're an open source project, github.com/code-.org. All of our source code's up there, so if you want to see some of the testing code that we have here, or if you're like, oh, maybe I'll try that thing out, you can find where in our code we did that. And we're always looking for contributions there, so just definitely ask me if you're interested in doing some sort of a side project. You can build one of our features or something. Yeah, that's me, Brian@code.org if you need to reach me, and I'll be here after to hang around. I'd like to open up to any questions. People have any questions about testing? Ideas for future things? Yes, Kristen. That's my wife, by the way.
Hi. I'm in the process of I'm not a programmer, but is
Sure.
there any testing programs or tools that will sort of random select different actions on your website? So instead of just you having to program how it goes, is there something that'll just
how it does
random
each thing?
do it?
That's a good question. The question was, is there something that will go through your website and do random stuff so that you don't have to say, hey, in my test, please do this random thing? That's a great question. It would be nice to not have to test stuff.
I have not shared that because that was a great start idea.
Oh, Startup, Kristen's going to be coming out with startup. So that's a good question. I think actually it seems like the challenging part of that, thinking about that. So there are actually one thing that we do use that's kind of like that is we use a link checker, a broken link checker that will crawl through our website and check for broken links. And sometimes that does find like pages that were supposed to work that didn't work. If they throw an error code, that'll tell us. But yeah, that's a good question.
There's
Yeah.
also a CS technique called genetic testing, which is actually basically that. It's like if you mutate it in this particular way, it'll create something new, but it doesn't end up being very helpful.
Super helpful. Genetic testing, cool. Mutation testing.
Yeah, I mean, so the thing I had running earlier was all written in Selenium, and it actually doesn't know what's on the page. It just looks for certain characteristics and then randomly picks one. That was
Oh, nice.
watching the wraps come up and swipe. It doesn't like I actually don't know what all those wraps are. I just plugged in all the URLs. I know the
It seems dangerous.
No, yeah. Trust me, I was
Wraps.
surprised with Victoria's Secret when it popped up. So, yeah, it's in the list. So you can kind of do randomization if you. I got to go to like within the behavior of the page I'm on, and then I just have randomly pick something, and so I like this infinite while loop that just keeps going and figures out whether I'm on this page, I'm going to do something.
That is cool. Yeah, actually, it seems like the tough part with that is when you do go to the page or do the action, how do you know, what's the assertion you're making? Like, did something change or like, I guess if you hook that up to Apple Tools, yeah, it's kind of, you just crawl the whole thing, do a bunch of stuff, and remember what you did and do it again. That could probably actually do something. Good startup idea right there. Yes?
Do you have any specific localization tests?
Could you repeat that?
You support a bunch of languages, so how do you test it?
So do we have any, so in terms of, let's see. Yeah, could you
So
explain
if
that?
you do assertion, right?
Right.
You have to have like a bunch of files.
Right.
Is it other languages, for example,
So our assertion tests written in like different languages than the language that the code's written in, or something like that, or like, do we test all languages? Yeah, we do have our, let me roll back to that Ruby slide, the slide about our different parts of our site. Yep.
She's talking about like languages, not programming.
Oh, languages. Oh, yeah, that's right. I was like, testing in that language. Yeah. Wait, I do have a slide for that too. Yeah, all right. That's the slide I swear I was going to. Yes, that's a great question. So we do have tests. There are kind of tests at all different parts. So we have tests in our UI tests. So when we're running through the Selenium, we do have tests that will run it in right to left mode. We have an eyes test, that Apple Tools eyes, that actually takes a screenshot of right to left. Make sure that doesn't change because that happens a lot. Within our Rails application, we have tests that say like, I'm going to make a request to this page, and I have this cookie that says I should get this language. It should have this language. Yeah. So we do have. I'm not sure actually if we have anything that automatically runs through every single language right now. I think we test like, choose a couple of languages here and there. But that's I think something that we do eventually want to do to make sure that as new translations come in, they didn't break any part of the site. Because oftentimes translations will come in with like some weird character that breaks some context that we're using it, or changes the variable name that sometimes we use to include stuff in the translation. So yeah, it was a great question. Any other questions? Yes?
What's your ramp-up time on the thing?
Setting it up. How long did it take to get it going?
Yeah, so if somebody's running a new project in Apple, what are the other doing components that are needed along with it?
To get it set up. Yeah, actually, so the Apple Tools test, it was just like probably like 5 lines of code. It was very small because it swaps in. It actually acts as you basically swap out. So at least for the Ruby Selenium bindings that we use, and it's probably similar for others, you can basically just swap out the browser object that's the default Selenium one for the Apple Tools one. So actually, theoretically, we could, instead of having separate Apple Tools tests, we could just change all of them to run the Apple Tools one, which would give us coverage of all of our Selenium tests. And I think actually some people do that. So it's worth a shot. And if all of your tests work like that, and then suddenly you have visual coverage of everything, and you just go in and mark the random stuff, it might even just be like a couple hours and those lines. It was actually very quick to get set up. It was just a few lines, and yep. That's worth trying out. Yep.
Was there any big challenge? It doesn't really use that many tools.
Oh, getting it set up?
Yeah, was there anything you ran into?
Let's see. Yeah, it's a good question. Any like challenges with Apple tools in general? Let me pull up something Apple Tool Z, so we have something to look at. Apple tools. Yeah, so what was challenging about getting Apple tools set up? I will say the one thing is getting all of your ignore regions set. So when you do a bunch of screenshots, great. App Tools is set up. It's all hooked up. Next time you run it, all these things change. So you go in and you say, okay, this is random. This is not random. This is random. Like nothing really like weird came up. Like no like quirks. I think at one point we did have our browser, our OS identifier would sometimes be slightly different, just from how we were requesting the browser ID. And so it was creating separate, it was kind of treating them as separate paths so our baselines would be kind of different. But so we fixed that just by kind of hard coding that. I think we had to force our resolution to always be exactly the same too, for the same reason that the baselines are kind of based on the specific string of the resolution in browser. I think that was the only hiccup we had. And then, it was just chasing down all the stuff that we just needed to use these things on. And those actually work pretty reliably. I don't think we've actually had one like false break. Like, if anything, it's just been like something on the web page changed and we had to change it. The only thing that I would say is kind of a pain point right now is if you make a change to your entire website. Let's say we changed like, I don't know, this X button or something to look different. All of our level tests are going to say, hey, like this thing changed. And you got to be like, okay. But actually they're coming out with a new interface this month, I think, that has like an accept all and like it actually is one view that shows you every small thing that changed right on the view instead of having to go into this interface. It's just like, see all these X's, and you're like, yeah. I think it might even collapse them too, so you're just like, yeah, that X looks good. So yeah, I've been surprised how, given having tried to make it as a hackathon project and getting like, I would get errors like different font rendering, sub-pixel changes, and I'm like, but nothing changed, I use the same thing. But I haven't seen any of that on here. I think they do a lot of cleanup or like higher level like difference checking to make that a little easier. Yeah, good question. Any other questions? Yes?
The differences in the tests that you run in Phantom.js versus Selenium are the ones that are in Selenium are just completely testing for differences between different browsers?
That's a good question. Yeah, so the question is basically, why write something in why write a Phantom.js test versus a Selenium test? I think in our case it wasn't really intentional. The dividing line I think for us was our Phantom tests we only ran very low level, almost unit testy stuff in Phantom because it's fast. I would say the one reason maybe we don't run some of the higher level assertion-y tests in Phantom is it is different from other browsers. So sometimes there are issues with Phantom, or Phantom will have trouble rendering certain things without tweaking them. Like I remember for the Minecraft hour of code, I had to make that work for the Phantom tests, and there were a couple of things I had to tweak about the underlying engine we were using to make sure that it worked within the Phantom browser. It's just kind of a different browser. But yeah, it's great for really quick tests. It's really fast. So it's definitely the case that we should probably change a lot of our tests over to faster versions. So like some stuff that we test in the browser, it's like make sure that this thing runs okay. It's kind of expensive time-wise to run that as an actual browser, Selenium browser test. Even ChromeDriver, it takes a little while to spin up the browser and run it. Phantom's really quick, so we should probably, it's probably something that we can improve at actually is finding good criteria for saying, this thing might be a cross-browser issue, let's just cover that. And then this other thing is probably not going to have anything to do with browsers. It's just logic, run that in Phantom. And we kind of do that, but it's kind of informal to some degree. Yeah, it's a great question. Yep, any other questions? Yes?
How many engineers do you have, developers?
Oh yeah, I meant to mention that. Yeah, I think we're around 12 right now. Yeah, I think the company in 12 total. Yeah, and then I think companies like 40, 50, probably 50 people now. So I think the bulk. We have an education team who works on the curriculum development. They actually we kind of build them tools to build a lot of the levels, the instructions. So the stuff I work on usually is not like coming up with cool levels and stuff. Sometimes, but not usually. That's always fun, but I'm not that good at it.
How do you distribute the work of, creating tests?
That's a good question. Yeah. I should have mentioned that. It's pretty. Okay, so the question was, how do we distribute the work of
You have, like, dedicated
making tests?
people doing tests, or you have
Yeah,
developers write their own tests?
we all write our own tests. That's right. So we're all kind of full stack to some degree. Like some people have specializations. Like I kind of work more on the tutorial stuff, the like JavaScript interactive-y stuff. Some of our engineers work a little more on like the website, front-end website, kind of like layout-y stuff. But yeah, we try to test our own stuff at the time of writing or after the time of writing. And then you're also kind of on the hook for maintaining that test. Like if we're getting yelled at in the chat room, like, hey, this thing broke. It'd be like, hey, do you know, if we don't see which commit actually caused it, we'll be like, hey, you kind of know this feature and wrote those tests initially. So, yep, it's all kind of, they who wrote it must then test it. Any other questions?
How many tests do you have?
How many tests do we have? That's a great question as well. I think we have, so I think in the Selenium test, for the Selenium test, I think we're up to, like between 100 and 300. I think maybe like 200. 200, oh, it's hard to say because there is the browsers too. So I think we have 12 browsers. We're running across 12 browsers. And then we have something like 100, I think it might be 144 individual features. So not like files, but individual test run, start to finish things. It's quite a few, and that's just on the browser test side. And then we have our JavaScript tests, ton of those. We have level tests too, which are basically just actually I think that's for our older levels. They assert that a certain level should work when you put in these certain blocks and at a kind of lower level than actually having the browser run it. Bunch of those, bunch of Rails tests. Yeah, quite a few tests. Yeah, it's definitely grown a lot over the last year and a half, I think, since. Yeah.
You kind of said this, but I'm just clarifying. So you have unit tests, you have Selenium tests. What are the JavaScript tests? Would they be kind of unit tests, or they do components?
What would I consider them? Yeah. So the.
A good example of one that's not really a unit test, but not really a Selenium test.
Not really a unit test. Not quite a Selenium test. Yeah. Well, so we'd have so in our Blockly tests. Where's that at? We actually run, I need to find a better way of jumping around here. Where's our website? We just need a website. There we go. That's kind of a thing. So in this Blockly core area right here, where we test the actual like dragging and dropping of blocks, in that we have a set of tests that are kind of integration tests in that it's like create a new block space, add a bunch of stuff to the block space, open up the function editor, and it actually opens it up in Phantom.js, and then like close it, and that runs really quickly. It's pretty much I guess that I'd call that an integration test, not a UI test maybe, just because you're not seeing it, but it is running the UI and it's making sure that it all works. So that I think is kind of one of the gray areas we have of like we put it there because it's faster. It's faster to run there. And if we don't think we're testing for a cross-browser issue, then we just do that. Yeah, but it is kind of a cloudy line, I'd say, between what we run as straight phantom tests, as he asked earlier, phantom tests versus like actual ChromeDriver real tests. Yeah, I'd be interested in like learning more about how other teams and companies handle that divide, or there's probably like some good phrase for each that we've kind of like YOLO'd a lot of the test stuff, like, oh, just get it tested. I forget we're not sure what we call it. We've always called them UI tests, but I think you're supposed to call them integration tests or something. And now it's even more confusing because we have Apple Tools eyes tests. And those really are kind of more UI because it's like that interface that you're looking at. So, yeah. Yep.
Stupid question, and maybe you already answered.
The button text.
That's
Do
my
you have
favorite.
any like full end-to-end user automated tests? When I was thinking when you were doing your presentation,
Yeah.
you do a test where you like execute a whole curriculum.
Yeah. That's actually a good question. So the question is, yeah, basically, do we have any like really end-to-end, just like start to finish sort of tests for some?
Something that like a student would do, you know.
Right, more of a simulation of what a real session would be. Yeah, that's a great question. So the one thing I would say is that's kind of, I think we kind of cover that, or we try to cover that a lot of the like pieces of that. It's like if you imagine the student logs in, they go to the thing, they do that. What we actually usually end up doing is writing those as separate little features files. Okay, they log in, great, it worked. Okay, you're on this page, or you're a student already, and you go to this page and you do the thing, it worked. One thing that I think would be the benefit of that kind of real end-to-end thing as you're describing is we could then, I think it's a lot faster than the time to like spin up a new browser and operating system and then run the test, close down the new browser, like versus just like, okay, just do the whole thing, right? But I guess the flip side of that then is we can parallelize these little chunk ones pretty massively. But yeah, I think that would probably help with speed to do that kind of all at once.
What you do has a lot of value, you know, chunking it up and all that.
Yeah.
But I'm also thinking about, you know, simulating real life kind of thing.
Right. There's probably stuff that within the full test that you might not capture within the specific test too. Good question. Any other questions, or how are we doing on time? All right, time for one more question. We'll say that. No, just kidding. If they're a bar. Any other questions? We're good. I'll be around, probably eating some of that food. There's a lot of good food left. Cool. All right. Thanks very much for coming out, guys.